ಇವರು ಮಹೇಶ್ವರಿ ಸರ್ದು
ಇದು ಕಾಣುತ್ತೆ ಅಂದರೆ ಮತ್ತೆ
ಇಲ್ಲಿ ಬಟನ್ ಒತ್ಬೇಕು
ನೀವು ಅಲ್ಲೇ ಓದ್ಕೊಳ್ಳಿ ಪ್ಲೀಸ್.
ಹೌದಾ?
ಏನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಓದ್ಕೊಡ್ರಿ. ಅದು ಅವ್ರೇನು ತಲೆ ಕೆಡಿಸ್ಕೊಂಡಲ್ಲ. ಓಬಿ ಜಾತಿ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ.
ಲಿಂಕ್ ಎಲ್ಲರಿಗೂ ಹೋಗಿದೆಯಾ?
ಅಲ್ಲೇ ಹಾಕ್ಬಿಡು ಫಸ್ಟ್ ಪೇಜ್ ಏನಾಗಲ್ಲ.
ಅಲ್ಲಿ ನಂಗೆ ಡಿಸ್ಪ್ಲೇ ಸರಿಯಾಗಿ ಕಾಣ್ತಾ ಅದು.
ಹೌದಾ?
ಹಲೋ
ಮಹೇಶ್ವರಿ ಸರ್
ಹಲೋ ಹಲೋ ಕೊಡಿ ನಿಮಿಷ ಅವರು ಮೀಟಿಂಗ್ ಇದ್ದಾರೆ ರೆಡಿ ಮೀಟಿಂಗ್ ಇದ್ದಾರೆ.
ಓಕೆ
ಕೊಟ್ಟಿದ್ದೀನಿ ಅವ್ರಿಗೆ ಕೋರ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಗೊತ್ತಾಗಲ್ಲ ಈಗ ಅವ್ರ ಬಗ್ಗೆ ಆನ್ ಮಾಡ್ಕೊಂಡು
ಓಕೆನಾ?
ಸದ್ಯಕ್ಕೆ
ಓಕೆ.
ಹಾಂ ಒಮ್ಮಿಜಿ ಕೊಟ್ಟು
ಯಾವ್ದು ಯಾರು ನಿಮಿಷ ಒಂದು
अभी रहने दो, बाद में अगर जब लेक्चर शुरू कर
ಅವ್ರಿಗೆ ಇನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಬೇಕು.
अभी तो फिर लंच के बाद आते हैं ना
ಏನು
ಸ್ಲೈಡ್ ಶೇರ್ ನಾನು ಮಾಡಿ ಅನ್ಕೊಂಡು ಹೇಳಿ
ಹೇಳ್ಬೇಕಾ?
ಹೇಳಿ.
ಓಕೆ ನೀನೇ ಹೇಳು. ನೀನು ಹೋಸ್ಟ್ ಅದೆಯಲ್ಲ ಇಲ್ಲ.
आप ज्वाइन कर रहे हो?
ಯಾರು ಬಂದರು
तो ये हमारे में आ रहा है,
डू वन थिंग
तो वो लोग करेंगे ज्वाइन. हो गया हमारे करने से
प्रोसीजर प्रकार
ಈ ಟೀಸರ್ ನೀವು ಹೇಳ್ತೀರಾ ಇವಾಗ ಯಾರಾದರೂ ಹೇಳ್ತೀರಾ?
ಏನು ಹೇಳಲ್ಲ.
ಇಲ್ಲ 2:30ಗೆ ಒಂದು ಟೀಸರ್ ಪ್ಲೇ ಆಗಬೇಕು. ಆಮೇಲೆ ಸ್ನೇಹಿತ
हम नहीं देख रहे होंगे ना.
ಗಾಲಿಗೆ ಹೋಗ್ತಿದೆ ಆಲ್ರೆಡಿ. ಲೈವ್ ಸ್ಟ್ರೀಮಿಂಗ್
ऑडियो बंद कर लो. आपका ऑडियो
ಆಫ್ ಇದೆಯಲ್ಲ ಎಲ್ಲ
ಬೇರೆ ಯಾಕಪ್ಪ ಜಾಯ್ನ್ ಆಗಿದ್ದಾರೆ. ಯಾರು ಧರ್ಮೇಂದ್ರ
ಪ್ರಜಾಪತಿ
ಯಾರಿಗೆ ಗೊತ್ತು ಅದು ಅವ್ರು ಕಳಿಸಿರುತ್ತೆ ಮೋಸ್ಟ್ಲಿ. ಆಯ್ತು ಸರ್ ಕಳಿಸಿರುತ್ತೆ.
ಅವ್ರಿಗೆ ಹೆಲ್ಪರ್ ಇರ್ತಾರೆ.
ಈಗ ಯೋಗನ ಸಹ ಜಾಯ್ನ್ ಆಗಲಿಲ್ಲ.
ಮೊದಲು ಟೀಸರ್ ಪ್ಲೇ ಆಗುತ್ತೆ. ಟೀಸರ್ ಪ್ಲೇ ಆದ ತಕ್ಷಣ ಎಲ್ಲರೂ ಒಳಗಡೆ ಬರ್ತಾರೆ. ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಎಮ್ ಐ ಆಡಿಬಲ್ ಕ್ಲಿಯರ್.
ಪಟೇಲ ಹಾಂ ಲಿಂಕ್ ನಾನು ನಿಮಗೆ ನಿಮಿಷ ವಾಟ್ಸಪ್ ಮಾಡೋಣ. ನನಗೆ ವಾಟ್ಸಪ್ ಮಾಡ್ತೀನಲ್ಲ.
ನಿನ್ನ ಕೈ ಇಟ್ಕೋಬೋದು.
ಅಮ್ಮ ಈಗ ಟೀಸರ್ ರೆಡಿ ಇರಲಿ.
ಸರ್ ಗುಡ್ ಆಫ್ಟರ್ನೂನ್.
नमस्कार, गुड मॉर्निंग, गुड आफ्टरनून.
Sir, how are you, sir?
I am fine. Now my video is visible now.
No, that they will put the teaser now. So I have put up this thing. Our college teaser they are going to put now. Then it will be continued, sir. Okay, sir?
Okay. So what I want to tell you, Nagaraj ji.
Yeah, tell me, sir.
Should I use the same link or
Same link I have.
So actually, okay, I will do one thing, that I will make my audio and video off. And okay, I am here only.
Yeah.
Is it okay?
Wait, sir.
Okay.
Sir, audio video off ಮಾಡಲ ಅವರು?
ಮಾಡಲಿ.
Okay, sir, you can put off your audio and video.
Okay.
ನಾವು ಆಫ್ ಮಾಡಬೇಕಾ?
ಈಗ ಚಾಟ್ ಮಾಡಲಾ ವಿಡಿಯೋನ? ಈಗ ಅಲ್ಲಿ ಫಸ್ಟ್ ಯೂಟ್ಯೂಬಲ್ಲಿ ನೋಡ್ರಿ, ಅದು ಬರುತ್ತೋ ಇಲ್ಲ ಅಂದ್ಕೊಂಡು ಹೇಳಿ, ಗೊತ್ತಾಗಬೇಕಲ್ಲ. ಲೈವ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಕಾಣಿಸಿದ್ರೆ ಅಲ್ಲಿ ಕಾಣುತ್ತೆ ನಿಮಿಷ ನೋಡ್ಬೇಕು ಇವಾಗ ಮ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ ಮ್ಯೂಟಿದೆ ಅದಕ್ಕೆ ತೊಂದರೆ ಇಲ್ಲ ಅದೇ ಮ್ಯೂಟಿದೆ 16 ಜನ ಬಂದವ್ರೆ
ಅಷ್ಟೇನಾ?
ಸಾಕು ಬಿಡಿ ಮ್ಯಾಮ್ ನಿಮ್ಗೆ ಯಾಕೆ ನೀವು ಸುಮ್ಮನೆ ಹೇಳ್ರಿ ಮ್ಯಾಮ್ ಇವಾಗ
ಅಷ್ಟೇ.
ಪ್ಲೇ ಕೊಟ್ಟಿಯಾ?
ಪ್ಲೇ ಕೊಟ್ಟಿಲ್ಲ ಇವಾಗ ನೋಡ್ತೀನಿ ಇಲ್ಲಿ ಬರುತ್ತೋ ಇಲ್ಲ ಹೆಂಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಹೇಳಿ ಯಾಕಂದರೆ ಈ ಸ್ಕ್ರೀನಲ್ಲಿ ಕೇಳುತ್ತೆ ಅದು ಸುಮ್ಮನೆ ಎಂಟೈರ್ ವಿಂಡೋನ ಕೊಟ್ಬಿಡ್ತೀನಿ ಎಂಟೈರ್ ಸ್ಕ್ರೀನ ಕೊಟ್ಬಿಡ್ತೀನಿ ಓಕೆ ಪ್ಲೇ ಮಾಡ್ತೀನಿ ನಾನು
ಟೀಸರಾ?
ಎಂಟೈರ್ ಸ್ಕ್ರೀನ್ ಕೊಟ್ಟರೆ ಯಾಕೋ ಬರ್ತಿಲ್ಲಪ್ಪ
ಇಲ್ಲ ಬಿಡಮ್ಮ.
ಹಾಂ
ಪ್ರೆಸೆಂಟ್ ಟ್ಯಾಬ್ ಅಂತ ಕೊಟ್ಟು ನೋಡ್ರಿ ಸ್ಕ್ರೀನ್ ಅಂದರೆ ಅದಷ್ಟೇ ಬರುತ್ತೆ
ಅಲ್ಲ ಈಗ ಟ್ಯಾಬ್ ಅಂದರೆ ಬೇರೆ ಟ್ಯಾಬಿಗೆ ಅದು ಅಂದರೆ ಗೂಗಲಲ್ಲಿ ಬರುತ್ತೆ ಅಷ್ಟೇ ಟ್ಯಾಬ್ ಅದು ಬೇರೆ ಕಡೆ ಬರ್ತಿಲ್ಲ ಇಷ್ಟಾವಿಂದ ಬರ್ತಿರೋದು
ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಂಡು
ನಾನು ಮೈಕು ವಿಡಿಯೋ ಆನ್ ನೀವು ಆನ್ ಮಾಡಿಸಿ ಸರ್, ಹೋಗಿ ಸರ್ ಆನ್ ಮಾಡಿಸಿ. ಮೈಕ್ ಆನ್ ಮಾಡಿದ್ದಾರೆ.
ಸೌಂಡ್ ಏನು ಕೇಳ್ತಾ ಇಲ್ಲ ನಮಗೆ ಅಭಿ, ನಮಗೇನು ಕೇಳ್ತಾ ಇಲ್ಲ.
ಅಷ್ಟೇ
ಸ್ಟಾರ್ಟ್ ಮಾಡಲ?
ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ ಮಾತಾಡ್ತಾರೆ.
ಇಲ್ಲಿ ಮಧ್ಯೆ ಒಬ್ಬರು ನಿಲ್ಸ್ಕೋಬೇಕು. ಹಿಂಗೆ ಹೋಗ್ಬಾರು ಹತ್ರ ಇದು. ಏನು ಸೌಂಡ್ ಕೇಳ್ತಾ ಇಲ್ಲಲ್ಲ?
ಜಸ್ಟ್ ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ಆಫ್ ಆಗುತ್ತೆ.
ಇದು ಹಾಂ ಇಲ್ಲತ್ತಲ್ಲ. ಹಾಂ ಇದು ಆಫ್ ಮಾಡ್ಬೇಕಾ?
ಹಾಂ, ನೀವು ಮಾತಾ
ದುರ್ಗಾ ಶರಣರು, ಪ್ರೆಸಿಡೆಂಟ್ SJM ವಿದ್ಯಾಪೀಠ ಚಿತ್ರದುರ್ಗ. I am Dr. Snehalata, Associate Professor and Head, Department of Pharmaceutics, SJM College of Pharmacy, Chitradurga. A warm good afternoon to all. It's my immense pleasure to welcome to the webinar on wisely employed solid shall replace harmful organic solvents in future. The concept is based on hydrotropy, mixed hydrotropy and mixed solvency. It's a great honor for me to welcome today's eminent speaker, Dr. R.K. Maheshwari sir, Professor, SGS Institute of Technology and Science, Indore, Madhya Pradesh. With immense happiness, I welcome our respected Professor and Principal, Dr. Nagaraja T.S., SJM College of Pharmacy, Chitradurga. I also welcome the supporting pillars of pharmacy field and HODs of all the various departments, teaching staff, research scholars, PG and UG students to this webinar. Now I would like to invite our principal to deliver keynote for today's webinar. Over to you, sir.
ಥ್ಯಾಂಕ್ ಯು.
ವಾಯ್ಸ್ ಕೇಳ್ತಾ ಇದೆಯಾ?
ಇಲ್ಲ ಬರ್ತಿಲ್ಲ. ವೈಷ್ಣವಿ ನಂದು ಹೆಂಗೆ ಬಂತು?
You are not audible. Nagaraj sir, you are not audible.
ನಾನು ಕಾಣಿಸ್ತಿಲ್ಲಲ್ಲ? ಥ್ಯಾಂಕ್ ಗಾಡ್. ಆಮೇಲೆ ಯಾವಾಗ ಬೇಕೋ ಅವಾಗ ಆನ್ ಮಾಡ್ಕೊಂಡ್ರೆ.
ಗುರುಬಸವಲಿಂಗಾಯ ನಮಃ. Seeking the blessings of His Holiness Sri Shivamurthy Muruga Sharanaru, it is overwhelming and joyful to be part of this webinar. As you all know, SJM College of Pharmacy is one of the best pharmacy institution in Karnataka. It was established in the year 1984 and is affiliated to Rajiv Gandhi University of Health Sciences, recognized by AICTE and Pharmacy Council of India, New Delhi. College also has accredited by NAC with B++ grade. Our college offers diploma in pharmacy, bachelor in pharmacy, master in pharmacy, PharmD and PhD programs. And has happy that our department of pharmaceutics has organized this wonderful webinar. Our today's resource person, Dr. R.K. Maheshwari sir, heartily I welcome you sir. Sir was my teacher at SCS College of Pharmacy, Harapanalli, Karnataka during 1983. Despite of his busy schedule, sir accepted our invitation and agreed to become resource person of today's webinar. Thank you sir. I hope in the today's topic, as you all know, the organic solvents are widely employed since they are going to dissolve, suspend, extract drugs that are not soluble in water. And organic solvents have central nervous system effects, which includes headache, dizziness, which progresses to the unconsciousness, seizures, and death. And it also eye, nose, and throat irritation may also occur with exposure to solvent mixtures. Sir has proved in his research studies by wisely employing solids shall replace organic solvents by using different techniques like hydrotropy, and mixed solvency. Sir, he is having profound knowledge on solubility studies. So, I request all the participants to make use of this wonderful session, and I thank you, sir. Now, over to Dr. Snehata, madam, for further proceedings.
ಮೈಕು ಹುಡಿ ಎರಡು ಆನ್ ಮಾಡ್ಕೊಂಬಿಡಿ ಬೆಟರ್.
Thank you, sir, for opening this session with wonderful words. It's my privilege to address a guest of honor, Dr. Rajesh Kumar Maheshwari, sir. Dr. R.K. Maheshwari, sir, is presently working as Professor, Department of Pharmacy, SGS Institute of Technology and Science, Indore, Madhya Pradesh. Sir is a gold medalist in MPharm Pharmaceutics in the year 1981 at Dr. H.S. Gaur University, Sagar, Madhya Pradesh. Sir completed PhD in Pharmaceutics in the year 2008 at School of Pharmacy, Devi Ahalya Vishwavidyalaya, Indore, Madhya Pradesh. Sir secured a certificate of merit from Ministry of Education and Society Welfare, Government of India. Sir awarded Indian Drug Manufacturers Association of Best Research Paper Award in the year 2005 in Pharmaceutical Analysis discipline. Sir has honored Eminent Researcher Award in the year 2012 at National Seminar, Bhopal. Sir is a recipient of Junior Research Fellowship from UGC during MPharm and Senior Research Fellowship from UGC during PhD. Sir has 33 years of teaching experience and guided 72 MPharm projects, 3 PhD projects, and more than 190 national and international research papers published. Sir has received several awards. Sir was a resource person and delivered more than 200 lectures at various seminars, workshops, and conferences. Sir's expert field of research in hydrotropy solubilization, mixed hydrotropic solubilization, and mixed solvency concept. Sir has authored several textbooks and filed 4 patents. Now I request our guest to take over the session. Dear participants, if any queries, please comment in YouTube chat box. Over to you, sir.
Okay. Good afternoon to all of you. Firstly, I would like to thank Dr. T.S. Nagaraj, principal of this college, who has invited me for this lecture. So I am thankful to him. And of course, also I am thankful for the management of your college because of whose effort this lecture has been planned. As you know, today's topic for this lecture is wisely employed solids shall replace harmful organic solvents in future. So in my lecture, you will find the utilization of solubilizing power of solids, cheap solids, safe solids, to replace harmful organic solvent. So this is the main thing which you will get in my lecture. Okay. Now up to this time, what happens? Whatever the substance is present in liquid state at room temperature, it is known as solvent. Water, ethanol, methanol, chloroform, etc. So whatever the substances they occur in liquid form, they all are known as solvent. But there is no universal solvent. Means there is no solvent which is good solvent for each and everything. We can say that each solvent, the so-called means liquid or so-called solvent, all solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. So this statement will be utilized in my lecture, and you will find the new thing which you will find in my lecture, that all the molecules which are present in this universe, all the molecules, whether they are the molecules of gas, they are the molecules of solid, they are the molecules of liquid, all molecules possess solubilizing power. Now I am going to start the presentation, and some doubts may come to your mind. So at the end of the lecture, there will be question answer session, and ask as many questions as possible.
ಆಯ್ತಾ?
I think it is visible. Ekra? Okay. Okay. Now, and this topic is more or less same. Solubilizing properties of solid cell replace harmful organic solvent. Okay. Now, something about the organic solvents. Various organic solvents are employed in various analytical techniques like TLC, HPTLC, HPLC, UV spectrophotometry, titanometry, etc. Also, organic solvents are involved in extraction of active constituents from herbal powders. Also, organic solvents are involved in synthesis of organic compounds. Also, organic solvents are involved in formulation of pharmaceutical dosage forms, in identification tests of drugs, etc.
ಹೇಳ್ತೀನಿ.
Now, the drawbacks of organic solvents. Organic solvents have numerous adverse effects caused by single exposure, like
ಅಷ್ಟೇ ಇರ್ತಾರೆ ಯಾವಾಗಲೂ
dermatitis, headache, drowsiness, nausea, irritation, etc. Long-term exposure causes serious ill effects such as neurological disorders, chronic renal failure, liver damage, neurosis, mutagenesis disorder, etc. Not only they are harmful for human being or for the health of humans, also they are costly. And one more drawback with organic solvents is that their disposal requires, means disposal means after they are used, when they are thrown away, a particular treatment is given for the organic solvents before they are thrown away. Okay, so another cost involving factor. So organic solvents are not only they are costly, but mainly they are harmful for human beings. Now some classes of organic solvent. Class 1 organic solvents include benzene, which is carcinogenic. Carbon tetrafluoride, it is very toxic for human being. It causes environmental hazard.
Sir,
1,2
sir,
huh?
sir, excuse me. That presentation you make it full screen, sir.
Acha.
Your presentation you make it full screen.
Acha. Okay, okay.
Okay, sir. Okay, okay.
Now it is okay. Yes, sir. Thank you. Now.
Now it's okay, sir. Okay. Carry on, sir.
Okay. Now, what happens in the dissolution? Simple theory of dissolution. Dissolution of a solute in a solvent involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. Means, for example, if you dissolve, say, for example, ascorbic acid in water, you get a clear solution. Why do we get a clear solution? As a result of hydrogen bonding and weak van der Waals forces between the molecules of ascorbic acid and molecules of water. If you are dissolving say ibuprofen in ethanol, you are getting a clear solution. Why? Because of the hydrogen bonding and weak van der Waals forces between the molecules of ibuprofen and molecules of ethanol. So this is the simple theory of dissolution. Here in this similarly, when I will explain you how can you say that gases have got solubilizing power, solids have got solubilizing power. When the molecules of gas or molecules of solid, when they are in liquid state, they can also be involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes. I will explain this in my lecture later on. Now, I have started a new concept known as mixed solvency concept. First time in the world in the year 2009. There are two important parameters of this mixed solvency concept. The first parameter of mixed solvency concept says that each and every substance, whether the substance is gas, whether the substance is liquid, whether the substance is solid. So each and every substance present in this universe has got solubilizing power. In other words, in simple words, you may say, whatever the number of molecules are present the dissolution of that particular solute. Now about the solvents, whatever matter exists in liquid state at room temperature is known as solvent. Each liquid or so-called solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similarly, each matter, whether it is a liquid, gas or solid, is known as solubilizer in mixed solvency concept. Molecules of all solids in liquid state, of course, and molecules of all gases in liquid state also possess good solubilizing power for some solutes and bad solubilizing power for other solutes. Now, how can we say that solids have got solubilizing power? Before giving the examples of solids, I would like to give the examples of gases. How can we say that all gases possess solubilizing power? You see, the molecules of a gas may come in liquid state by two ways. Number one, if you liquefy a gas, as in supercritical fluid technology, CO2 is liquefied. Any gas, if you liquefy, or if you dissolve a gas in a particular solvent, then the molecules of gas will come in liquid state. Okay, and then these molecules of gas in liquid state may be involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes for their dissolution. Now I am giving the example of liquefaction. In supercritical fluid technology, we know that liquefied CO2 at a particular temperature and pressure is being used as solvent to carry out different functions. For example, to prepare nanoparticles or the extraction of active constituents from herbal powder or purification of the materials. So ultimately, liquefied CO2 is being used as solvent to carry out these functions because the molecules of CO2, they are in liquid state. That's why these molecules of CO2 in liquid state, they are involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes. Okay, now we have to see how can we say that this liquefied CO2 is solvent. You see, this liquefied CO2 is good solvent for some solutes and bad solvent for other solutes. How can you say that it is bad solvent for other solutes? Sometimes to potentiate the solvent power of this liquefied CO2, we have to add co-solvents like ethanol, methanol. This means for such substances where you require ethanol, methanol, etc. as co-solvent, for these solutes, this your liquefied CO2 is poor solvent. So in this way, now it is proved that liquefied CO2 is good solvent for some solutes where you do not require co-solvent, and liquefied CO2 is bad solvent for those solutes where you require ethanol, methanol, etc. as co-solvent. So it is proved that liquefied CO2 is a solvent. In the same way, if you liquefy any gas, nitrogen, helium, oxygen, etc., that will also be good solvent for some solutes and bad solvent for other solutes because the molecules are present in liquid state for hydrogen bonding and weak van der Waals forces for the dissolution of the solute. Okay, now this was one way by which the molecules of its gas may come in liquid state. Now another way by which the molecules of a gas may come in liquid state is by dissolution in a solvent. For example, we know concentrated hydrochloric acid. Concentrated hydrochloric acid contains about 38% weight by volume dissolved HCl gas. Means 100 gram of concentrated HCl contains about 38 gram dissolved HCl gas. Now the molecules of this HCl gas, they are in liquid state in this concentrated HCl. Okay. Now the solubility of nalidixic acid in water is very poor. The solubility of nalidixic acid in water is very poor, but in concentrated hydrochloric acid, the solubility is about 5%. 5% means very good solubility. Of course, we are not making any formulation at this time. We are just seeing the proof that gases also have got solubilizing power. Now, so what is the reason for solubility enhancement in concentrated HCl, that of this nalidixic acid, is again the reason is same. The molecules of HCl, they are available in liquid state or hydrogen bonding and weak van der Waals forces with the molecules of nalidixic acid. That's why there is large solubility of nalidixic acid in concentrated HCl. Okay, so these were the proof that gases have got solubilizing power. But if we utilize the solubilizing power of gases, it is costly affair. So we are keeping them, means gases, aside. Now, in most of my lecture, you will find the utilization of solubilizing power of solids. So now I am giving the proof. How can we say that solids have got solubilizing power? The molecules of a solid may come in liquid state by three ways. Number one, by melting. Number 2, by dissolution in a solvent. Number 3, by eutectic formation. All these examples I will give you just. Once the molecules of solid come in liquid state, the molecules of solid can be involved in hydrogen bonding weak van der Waals forces with the molecules of solutes. Now the examples of melting. Now, if you take urea is a solid of melting point 132 degrees centigrade. If you take 1 gram urea in a test tube, you keep it on heating mantle, it will melt at about 132 degrees centigrade and you will get 1 gram clear colorless melted urea in your test tube, which can be shaken just like water, means just like any liquid. So you are having a 1 gram clear colorless melted urea liquid at 132 degrees centigrade. Okay, this liquid nicely dissolves 1 gram of diclofenac sodium. Diclofenac sodium 1 gram is nicely dissolved by 1 gram melted urea liquid. Okay, now two things I have to mention here. Number one, the melting point of diclofenac sodium is 283 degrees centigrade and the melting point of urea is 132. So at 132 degrees centigrade, sodium diclofenac sodium does not melt because its melting point is 283 degrees centigrade, much higher than 132 degrees centigrade. That's why there is no melting of diclofenac sodium. Okay, then what is happening? There is a dissolution of diclofenac sodium in melted urea liquid. If you cool it, it will solidify. It is different thing. But at 132 degrees centigrade, which is the melting point of urea, urea is very good solvent for dichloride sodium. What is the reason? And of course, we are not making any formulation. We are just seeing the proof that how can you say that solids have got solubilizing power. So what we are observing that melted urea is good solvent for dichloride sodium. Suppose there was no solubilizing power in melted urea molecules, then you could have obtained a suspension of dichloride sodium in melted urea liquid. Okay. Now, what is the reason for nice solubility? Reason is same. The molecules of urea are available in liquid state for hydrogen bonding and weak van der Waals forces with the molecules of dichloride sodium. That's why there is dissolution of large quantity of dichloride sodium in melted urea. So this is the proof. Number two, if you take the example of phenol melting point 44 degrees centigrade. In your test tube for 1 gram phenol, water bath, you are heating it at about 44 degrees centigrade. Again, you are having 1 gram clear colorless melted phenol liquid. This liquid is very good solvent for nalidixic acid. It nicely dissolves 500 milligram of nalidixic acid. 1 gram melted phenol liquid nicely dissolves 500 milligram nalidixic acid, means about 50% solubility, 40-50% solubility is there. Again, the reason, of course, we are not taking any formulation here. We are seeing the proof that there is a solubilizing power in phenol molecules. Phenol molecules are available in liquid state, and these are responsible. Means the molecules of phenol are responsible for hydrogen bonding and weak van der Waals forces with the molecules of nalidixic acid. That's why there is large solubility of nalidixic acid in melted phenol. We are not making any formulation, just we are seeing the proof that how can we say that solids have got solubilizing power. Another way by which the molecules of a solid may come in liquid state is by dissolution in a solvent. Now, first solvent, say water. Okay, in water, the solubility of ibuprofen is very poor. 0.028% weight by volume, very poor solubility of ibuprofen in water at room temperature. Okay, if you imply 28.8% weight by volume solution of sodium benzoate in water, means a concentrated solution of sodium benzoate in water. In this solution, the solubility of ibuprofen is about 2.390% weight by volume. So 2.390 divided by 0.028 means about 85-fold solubility enhancement is there in the solubility of ibuprofen in sodium benzoate solution. Why? What is the reason for this? The molecules of sodium benzoate in this concentrated solution of sodium benzoate, the molecules of sodium benzoate, they are available in liquid state. And these molecules are involved in hydrogen bonding and weak van der Waals forces with the molecules of ibuprofen. That's why there is a large solubility of ibuprofen in sodium benzoate solution. Okay, of course, we are not making any formulation at this time. We are seeing the proof that a solid has got solubilizing power. Means this your sodium benzoate, which is solid at room temperature, when it is dissolved, the molecules come in liquid state, and now it is acting as solvent. Okay. Now number two, the solvent is ethanol. Ethanol is poor solvent for furosemide. Furosemide has got poor solubility in ethanol, 1.7% sparingly soluble drug in ethanol. Okay. If we prepare a 15% weight by volume solution of niacinamide in ethanol, 15% weight by volume solution of niacinamide in ethanol, the solubility of furosemide is about 5%. 5%. 5 divided by 1.7 is about threefold enhancement in solubility is there. Again, what is the reason for solubility enhancement in niacinamide solution in ethanol, that of furosemide? Because the molecules of niacinamide now they are available in liquid state, and these molecules are involved in hydrogen bonding and deep van der Waals forces with the molecules of furosemide. That's why there's large solubility of furosemide in this solution. Okay, so this is again a proof that the solid has got solubilizing power. Of course, we are not making any formulation here, but we are seeing a proof. Now, third solvent, propylene glycol. It is a weak solvent, poor solvent for pyroxicam. The solubility of pyroxicam in this propylene glycol is about 5 milligram per ml. 5 milligram per ml. But the solubility of pyroxicam in a solution containing two dissolved solids, 10% weight by volume sodium acetate and 10% weight by volume sodium caprylate in propylene glycol, you get a clear solution. So total strength is 10 plus 10 means 20%. So 20% are the dissolved solids in propylene glycol. In the solution, the solubility of pyroxicam is about 120 milligram per ml. 120 milligram per ml means 120 divided by 5, about 24-fold enhancement in solubility is there. Again, the reason for solubility enhancement is this, that the molecules of sodium acetate and molecules of sodium caprylate, they are available in liquid state, and these molecules are also involved in hydrogen bonding and weak van der Waals forces with the molecules of pyroxicam. That's why there is a large solubility. Although we are not making formulation at this time, but we are seeing the proof. So these were the examples of dissolution. Now by eutectic formation, if you take say thymol and menthol in equal proportion, suppose you take 10 gram thymol, 10 gram menthol, you triturate in pestle mortar, you get a clear colorless liquid at room temperature. Okay, so this is known as eutectic liquid of thymol and menthol. The pH of this is neutral, 6.5. Okay, now the properties of this eutectic liquid. This eutectic liquid is good solvent for these compounds, left-hand column compounds, and it is bad solvent for right-hand column compounds. You see the solubility of metronidazole benzoate. Metronidazole benzoate is a poorly water-soluble drug. Okay, but here 1 ml of this eutectic liquid nicely dissolves 200 milligram of metronidazole benzoate, means about 20% solubility is there. Of course, we are not making formulation, but what we are saying, very good solubility in this eutectic liquid. This means this metronidazole benzoate is having very good solubility in this eutectic liquid. Similarly, this eutectic liquid is good solvent for atenolol, 9% solubility, arnidazole 12%, benzocaine 12%, eutros like this. So for all these compounds, this eutectic liquid is good solvent. Again, if you take 1 ml of this eutectic liquid and 5 milligram of cetronidazole, even 5 milligrams cetronidazole is not dissolved completely by 1 ml of this eutectic liquid. Means this eutectic liquid is bad solvent for cetronidazole. Okay. Similarly, this eutectic liquid is bad solvent for all these compounds. Okay. Similarly, if you see some of the liquid, ethanol, propylene glycol, benzyl alcohol, they have got good solubility or miscibility in this eutectic liquid, but glycerin and water, they are immiscible in this eutectic liquid. So in the same way, you may check thousands of compounds for solubility in this eutectic liquid. When you will check solubility, some will fall in this column, some will fall in this column. So now you may say this eutectic liquid is good solvent for some compounds, it is bad solvent for other compounds. Just like solvents, I told you whatever the name of any solvent you take, whether it is water, ethanol, methanol, chloroform, it is good solvent for some solutes and bad for others. Similarly, this eutectic liquid is good solvent for some compounds and bad solvent for some compounds. This means this eutectic liquid is a solvent. And once it is proved that it is a solvent, this means whatever it contains two solids, thymol and menthol. They must have solubilizing power. That's why this eutectic liquid is good solvent for some compounds and bad solvent for other compounds. Again, what is the reason for solubility enhancement? The molecules of menthol, molecules of thymol, they are in liquid state in this eutectic liquid, and these molecules are involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes for their dissolution. Now coming to hydrotropy. Hydrotropic solubilization. So up to this time, we have seen that solids have got solubilizing power. Okay. Now we have to start the use of solubilizing power of solids to replace harmful organic solvent. So very cheaper method I am going to explain to you, that is hydrotropic solutions. Hydrotropic solutions are very safe solutions, economic solutions, and they can be employed particularly in the analysis of drugs to replace harmful organic solvent. So before this, we have to see what is hydrotropic solubilization. Hydrotropic solubilization is about 100 years old concept. 100 years old concept. Okay. Now let me give some example. Then I will define the hydrotropic solubilization. So you see this urea is one of the hydrotropic. Actually, this table gives us some of the hydrotropic. Is it? Now urea. If you make a 60% weight by volume solution of urea in water, 60% weight by volume solution in water, means from the point of view of students, I am telling that if you take 60 gram urea in a 100 ml volumetric flask, add sufficient distilled water and dissolve, and then make up the volume up to 100 ml, you will get 60% weight by volume solution of urea. In this particular solution of urea, the solubility of dichlorofonic sodium is about 4.8%. We are not talking about any formulation, but we are saying that the solubility of this dichlorofonic sodium in this 60% weight by volume urea solution is about 4.8%. 4.8%. Otherwise, the solubility of dichlorofonic sodium in water at room temperature is about 1.6%. 1.6% in water, 4.8% in 60% urea solution, hydrotropic solution. Okay, now why 4.8 upon 1.6 is about threefold enhancement in solubility is there. What is the reason for solubility enhancement here? The reason is the molecules of urea, they are available in liquid state, and these molecules of urea are also involved in hydrogen bonding and weak van der Waals forces with the molecules of dichlorofonic sodium. That's why there is large solubility of dichlorofonic sodium in urea solution. Okay, so this is one example of hydrotropic solubilization. Actually, hydro means water. This hydrotropic solubilization relates with solubility enhancement in water or in aqueous solutions. This is hydrotropic solubilization. This was first example. Number two, if you make 45% solution of sodium citrate, 45% weight by volume solution of sodium citrate in water, means a concentrated solution of sodium citrate. In this solution, the solubility of salicylic acid is about 15%. Otherwise, the solubility of salicylic acid at room temperature in water is about 0.3%. 0.3. So 15 divided by 0.3, about 50-fold enhancement, 50-fold enhancement in solubility is there. Again, the reason for solubility enhancement is the molecules of sodium citrate are available in liquid state for hydrogen bonding and weak van der Waals forces with the molecules of salicylic acid. That's why there is a large solubility of salicylic acid in concentrated solution of sodium citrate. So this is another example of hydrotropic solubilization. Third example, sodium benzoate. If you make 30% weight by volume solution of sodium benzoate in water, it means a concentrated solution of sodium benzoate in water. In this solution, if you check the solubility of several poorly water soluble drugs like that of ofloxacin, gatifloxacin, trinidazole, metronidazole, nalidixic acid, hydrochlorothiazide, paracetamol, gatifloxacin, brufen, this ibuprofen, flurbiprofen, naproxen, etc. for all these which are poorly water soluble drugs, their solubility is sufficiently enhanced in concentrated solution of sodium benzoate. The reason is same, the molecules of sodium benzoate are available in liquid state for hydrogen bonding and weak van der Waals forces with the molecules of these drugs. That's why you get large solubility in concentrated sodium benzoate solution. So these were the simple three examples of, you may say, the hydrotropic agents, and of course these were the examples of hydrotropic solubilization. Hydrotropic, again you listen, hydro means water, means aqueous solution or in water when the solubility enhancement is there. It is this is hydrotropic solubilization, but its a definition is when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent. Agent means these agents. Okay, of course there are. This is a small list of hydrotropic agents. So when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, then we call this phenomena to be hydrotropic solubilization phenomena. Now I will give the application part of this. We can derive the green pharmacy or green chemistry using these hydrotropic solutions, which can replace harmful organic solvent. Now, one more thing, let me tell you, those students or teachers who want this PowerPoint presentation for more references, then they can ask me by WhatsApp or by email ID. Later on, at the end of the lecture, I will give my WhatsApp number and, of course, the email ID. So anyone, whether you are a student or teacher, you may ask, I can send it to you. Because you see, I cannot give much time for giving all these examples. But here, in further my lecture, you will find this 2 molar sodium benzoate means examples of hydrotropic solubilization. 2 molar sodium benzoate means 28.8% weight by volume aqueous solution of sodium benzoate. 2 molar niacinamide means 24.4% niacinamide solution in water. 10 molar urea means 60% weight by volume urea solution in water. 1.25 molar sodium citrate means 40% weight by volume sodium citrate solution in water. 4 molar sodium acetate means 33% weight by volume sodium acetate solution in water. So, like here you see, these are other examples of hydrotropic solubilization. Here, if you see that for aspirin, distilled water solubility at room temperature is 0.131%. 4 molar sodium acetate, 7.4%. 1.25 molar sodium citrate, 4.7%. 2 molar sodium benzoate, 3.1%. Like this. So there are a large number of hydrotropic examples in. Okay, now I will do the application part of this hydrotropic solubilization. So firstly, I will discuss this part, means eco-friendly tritymatic analysis of poorly water soluble drugs using hydrotropic solution without using any organic solvent. Now here the example is that of furosemide API. API is active pharmaceutical ingredient, bulk drug. IPBP method, they are same. How there is assay of furosemide by pharmaceutical method? Weigh accurately about 0.5 gram furosemide API. You have weighed it, then dissolve in 40 ml of dimethyl formamide. You get a clear solution because dimethyl formamide is a good solvent for furosemide, class 2 organic solvent. Okay, then you titrate with the help of 0.1 molar NaOH solution using bromothiamine volume solution indicator. Suppose you get endpoint at x1, means the value of the volume of 0.1 molar NaOH required is x1 ml, x1 ml. Okay, then you will carry out a blank determination. How the blank determination is carried out? You will take a neat and clean another conical flask, add 40 ml of dimethyl formamide, few drops of bromothiamine volume indicator, and you will run 0.1 molar NaOH for color change. Suppose color change takes place at Y1 ml of 0.1 molar NaOH. So this NaOH has been consumed by your solvent system, 40 ml dimethyl formamide. So this has been consumed in previous case also. So this means Y1 ml will be subtracted from X1 ml. So X1 minus Y1 ml, this is called as a blank determination, correction. Okay, so this much volume of NaOH has been utilized for the tritymatic analysis of furosemide. Then using this factor, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. You can find out the drug content of your API. Okay, what is happening here? you are using a class 2 organic solvent dimethyl formamide. Okay, why pharmacopoeia did not use ethanol? Ethanol is a safer class 3 organic solvent. Its vapors are not harmful as the vapors of dimethyl formamide, they are harmful. But the vapors of ethanol, they are not so harmful. But why pharmacopoeia persons, they could not use ethanol? The reason is the solubility of furosemide in ethanol is poor, 1.7%, sparingly soluble. So they have implied a good solvent, but it is a class 2 organic solvent, harmful organic solvent, and they are carrying out this titration. Now I will tell you, number one, here itself I will tell you how can you utilize this ethanol by potentiating its solvent power. Ethanol alone, it is 1.7%, sparingly soluble. Now, in place of this 40 ml dimethyl formamide, I have used 40 ml of a niacinamide solution in ethanol, 15% strength. Ethanol containing 15% dissolved niacinamide. Now, because of this niacinamide solid, the solubility of furosemide has been increased in ethanol. This solution. Now you will dissolve API in this solution, 40 ml. Then you will use this bromothione indicator 0.1 molar anyway, blank determination and all that. So actually, in this way also you can titrate, you can assay the furosemide. So please listen me. What we have done, we have made a class 3 organic solvent ethanol like a class 2 organic solvent, just like dimethyl formamide, by solubilizing power of a solid niacinamide, which is safe. Okay, so because in this solution, if there will be vaporization of ethanol, it is not so harmful as the vaporization of dimethyl formamide is harmful for human being. Okay, so I'm telling you the way you can potentiate the solvent power of class 3 to make them as strong solvent as class 2 organic solvent or class 1 organic solvent. Okay, so this was one method. Means you can replace dimethyl formamide by ethanol by dissolving niacinamide. But another way, which is very economic and safe also, and that is hydrotrophic solubilization. In this, what you will do, we have to weigh accurately 0.5 gram furosemide API, dissolve in 40 ml of 30% weight by volume sodium benzoate solution. You will get a clear solution because of hydrotrophic solubilization, you say, or because of the solubilizing power of molecules of sodium benzoate by hydrogen bonding and weak van der Waals forces. You get clear solution. Okay, then you will add few drops of bromothione value indicator and run 0.1 molar annual solution for color change. Suppose the endpoint comes at x2 ml of annual solution, x2 ml. Okay, then you will carry out a blank determination using 40 ml of 30% sodium benzoate solution in another conical flask, neat and clean, few drops bromothione value indicator and 0.1 molar NaOH for titration. And color change suppose takes place at Y2 ml of 0.1 molar NaOH. This means this much has been consumed by sodium benzoate system. And of course, these are very small values, 1 ml, 2 ml like this. Okay, then this Y2 will be subtracted from X2. So X2 minus Y2 ml, this much volume of NaOH has been consumed by your drug. Okay, now using the same factor, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. You can find out the drug content. Now you see what is the beauty of this method, this hydrotrophic method or eco-friendly method. Here you are using a safe solvent system, sodium benzoate solution. Okay, this the cost of this 30% sodium benzoate solution in water is about 40 rupees per liter. Otherwise, the cost of your this ethanol, methanol, chloroform, dimethyl formamide, etc. is 200 rupees per liter, 300 rupees per liter, and so on and so forth. So not only your method is economic, but main thing is without using any organic solvent, you are able to perform the titrimatic analysis of this poorly water soluble drug. Okay, so this is the beauty of this method. 100% safe results are there. Now, in the same way, now I will not explain in so much detail. Now, in the same way, flurbiprofen API, IPBP method involves the use of ethanol for its dissolution. Now, this ethanol has been replaced by sodium benzoate solution in the same way as in case of furosemide. Naproxen API, tritematic analysis involves the use of methanol, class 2 organic solvent. Methanol has been replaced by sodium benzoate solution in the same way. Means without any organic solvent, you are able to perform the tritematic analysis. Salicylic acid assay involves the use of ethanol. This can also be replaced by sodium citrate solution. This is also very good hydrotropy agent for salicylic acid, and of course it is also cheaper. It is also cheap. Okay, so this solution can be used for tritematic analysis of salicylic acid. This can be checked by the students in the colleges, because all the colleges definitely they possess this salicylic acid and of course the sodium citrate and all that. Now ketoprofen involves the use, means assay involves the use of ethanol class 3, but this sodium benzoate can be used to replace this ethanol. Ibuprofen API utilizes ethanol, can be replaced by sodium benzoate solution in the same way. Now this method I will use in somewhat detail. Assay of ibuprofen tablets as per IP-BP method, they are same. IP method, BP method, they are same. Weigh and powder 20 tablets to find out average weight. Then weigh accurately the powder equivalent to 0.5 gram of ibuprofen, your weight. Then extraction with chloroform is done in pharmacopeial method. Then chloroform is removed in air current. When you get a semi-solid residue that is dissolved in 100 ml of ethanol, you get clear solution in ethanol. Then titration is done with 0.1 molar NaOH solution using phenolphthalein as indicator. Carry out the blank determination. For blank determination, you will have to use 100 ml ethanol in a separate conical flask. Each ml of 0.1 molar NaOH is put into this much gram of ibuprofen. So what we are seeing here, there is involvement of two organic solvents. Ethanol, class 3 organic solvent, and chloroform, class 2 organic solvent. Now you will see hydrotrophic method which will replace both these organic solvents. Now weigh the tablet powder, this is the eco-friendly method, hydrotrophic method. Weigh the tablet powder equivalent to 0.5 gram ibuprofen. Shake briskly for 10 minutes with 100 ml of 30% sodium benzoate solution. During this 10 minutes of shaking, the sodium benzoate solution dissolves the ibuprofen present in the tablet powder. So this ibuprofen has come in solution form. Then titration is done with 0.1 molar NaOH using phenolphthalein solution as indicator. Then blank determination is carried out using 100 ml of 30% sodium benzoate solution in another neat and clean conical flask in the same way as I explained earlier. Now, in this way, using the same factor, 1 ml of 0.1 molar NaOH is equivalent to this much gram of ibuprofen. You can assay, you can find out the drug content of your ibuprofen tablets. Okay. Now, what is the beauty of this method? There is no involvement of ethanol, no involvement of chloroform. Just by using the solubilizing power of sodium benzoate, you are able to perform the tritematic analysis of ibuprofen tablet. Okay, so of course the reason is same. You are utilizing safe and economic or solid sodium benzoate. When you dissolve it, that acts as solvent only, and you are able to perform the tritematic analysis. If you have any question, please note down that questions. At the end of the lecture, we shall have question answer session. Now, in the same way, tritematic analysis, in ethyl vanillin, indomethacin, glibenclamide, they utilize these organic solvents. These organic solvents can be replaced by hydrotrophic solution. Okay. Now, after tritematic analysis, UV spectrophotometric analysis of poorly water soluble drugs without organic solvent. Now, in this, the example is that of assay of tindazole tablet. Tindazole is poorly water soluble drug. IPBP method. They say to utilize methanol for its estimation. Weigh tablet powder equivalent to 0.15 gram of tindazole. It is kept together with 20 ml of methanol in a 100 ml volumetric flask, and then it is shaken. So during this time, whatever the tindazole is present in tablet powder, it goes in solution. Then volume is made up to the mark, up to 100 ml with methanol. Then filtration is done to remove insoluble excipient. Then from that filtrate, 10 ml of filtrate is diluted up to 100 ml with methanol. From this solution, again you take 10 ml and dilute it up to 100 ml with methanol. Then the absorbance of this solution is noted against methanol reagent blank at 310 nm. Means what you are doing, you have to note the absorbance at 310 nm, at which the peak of drug is there against methanol. Methanol is there in reference cover. In sample cover, this solution is there. The absorbance is noted. Then calculate the content of tindrazole taking 356 as the specific absorbance at 310 nm. Okay, you can find out the drug content using this E1% 1 centimeter value is specific absorbance. Okay, so what is the you are in here methanol, which is a close to organic solvent, is involved in this analysis. Okay, now this methanol can be replaced by the hydrotrophic method or eco-friendly method. Here you have to weigh tablet powder equivalent to 50 milligram of tindrazole. Add, what do? You take tablet powder equivalent to 50 milligram of tindrazole in a 25 ml volumetric flask. Then you add 20 ml of 30% sodium benzoate solution, aqueous solution, and then you shake the flask for 10 minutes. During this 10 minutes shaking, the tindrazole which is present in the tablet powder is being dissolved by sodium benzoate solution. Then make the volume up to 25 ml with distilled water and filter. You see, further dilution is with distilled water. Further dilution is not with sodium benzoate solution. Okay, so up to the mark 25 ml, you are diluting with water, and then you are doing this filtration to remove insoluble excipient. From the filtrate, you take 1 ml filtrate and dilute it up to 100 ml with distilled water. Okay, then the absorbance of this solution is noted at 318 nm against reagent blank. Now, from the point of view of the students, let me explain what is this reagent blank. In this reagent blank, you will make in this way: 25 ml neat and clean volumetric flask, 20 ml of 30% sodium benzoate solution, distilled water dilution up to 25 ml, then 1 ml of this solution diluted up to 100 ml with water. Now this solution is the reagent blank for this. So this reagent blank is kept in the reference cuvette, and the sample solution is kept in the sample cuvette. Okay, and then you note down the absorbance at 318 nm. Okay, now what is this reagent blank? Reagent blank means solution containing the sodium benzoate in the same amount or same concentration which is present together with the drug. As you have seen in the case of drug, we have gone in the same way, and then for reagent blank also we have gone in the same way. The concentration of sodium benzoate is same in both the cuvettes. So now there is a neutralization of the effect of sodium benzoate in both the cuvettes, and you get just the absorbance due to your drug only. Okay, you have noted the absorbance at 318 nm. One more thing, let me tell you. In case of water or aqueous solution, the peak comes at 318 nm. But in case of methanol, it is 310 nm. IPVT method, methanol, 310 nm. Aqueous solution, 318 nm. Due to change in solvent, there is shifting of peak. Okay. Now, after you note down the absorbance, now what you have to do? Calculate the content from the absorbance obtained by repeating the whole procedure using 50 milligram of tindrazole reference substance in place of tablet powder. Means one more absorbance you have to note, then you will compare the two absorbances to find out the drug content. So what you will do, the bulk drug, or you will say the pure drug sample of tindrazole having known concentration of tindrazole. For example, we know we get the samples from the industry, and that they are right. It is written that this tindrazole sample contains 98.93% of tindrazole. So this is known as reference substance. So based on this content, drug content, you have to take 50 milligram of tendrazole, standard drug, standard substance, 50 milligram, in a 25 ml volumetric flask, 20 ml of sodium benzoate solution, and means shaking to dissolve it to get clear solution, up to the mark with water, dilution with water, 1 ml from this diluted up to 100 ml with water, and you find out the absorbance against reagent blank. In the reference caveat, you will give the same reference reagent blank which you have utilized earlier. Reagent blank is common in both these operations. Okay, then by comparison of these two absorbances gives the concentration or you say the drug content of your tendrazole tablet. This is one way by comparison of the absorbances. Another way may be you can plot a calibration curve using standard uh, substance, tendrazole standard substance. You can make 5, 10, 20, 15, 25 like this μg per ml solutions, and the corresponding reagent blanks, and then you can note down the absorbances, then you can plot this calibration curve, you can find out the integration equation that can also be utilized to, uh, to compute the value of this tendrazole tablet strength and all that. Okay, so what is the beauty of this method? That firstly you understand that sodium benzoate does not interfere above 290 nm, above 292, above 292 nm sodium benzoate does not interfere. Here you are taking the absorbance at 318 nm. 318 nm is away from 292, so there is no interference of sodium benzoate. Okay, uh, and this method is economic because the cost of this 30% sodium benzoate solution is about rupees 40 per liter, and here further dilutions are always with distilled water, so economic method. Okay, and in previous method of IPBP method, they are using methanol, which is a class 2 organic solvent, harmful, the vapors are harmful for human beings. In the same way, UV analysis of naproxen tablets has been done by sodium benzoate solution, replacing methanol. In case of indomethacin, estimation was done at 320 nm using sodium benzoate solution, replacing this methanol. Naproxen is estimation is done at 331 nm. Diazepam 354 nm. Mixed hydrotropy has been used to replace methanol. So many published papers are there, in not only from India but also from abroad. So these methods are very useful. Now, other examples are atenolol tablets, dichloromethane sodium tablet. Atenolol tablet estimation is done using methanol by IPBP method. In the same way, dichloromethane sodium tablet estimation is done with methanol. This methanol of both these tablets methods has been replaced by urea solution. Urea does not interfere above 240 nm, 240 nm above. Urea does not interfere, and we have to estimate atenolol at 275 nm and dichloromethane sodium at 276 nm. So there is no interference of urea in these estimations. So urea solution, which is also economic solution, safe solution, has replaced methanol, which is a class 2 organic solvent. Now, identification test I am doing now, TLC. TLC can be done using hydrotrophic solutions. Now, here is the reference. It is given here. Ciprofloxacin and hydrochloride IP method always they involve dichloromethane and then your methanol, acetonitrile. In case of guaifenesin, carbon tetrachloride, which is a class 2 organic, no, it is class 1 organic solvent. Okay, are very harmful organic solvent, and ethanol, class 3. Piperazine citrate, acetone, and ammonia 4. And this one, toluene, and methanol, and all that. Okay, so what we have found here that without the use of any organic solvent, you are able to perform the TLC. Now you listen one sentence from me that for each and every compound, whether it is water soluble, whether it is water insoluble, you can perform its thin layer chromatography using hydrotrophic solutions or mixed hydrotrophic solutions or mixed solvent systems. Means without any organic solvent also you can perform the TLC. Now coming to HPLC, this is the published paper of Remy Madam. Remy Madam is assistant professor in Kerala. You see this Remy madam. She is assistant professor in Kerala University. She is doing PhD on hydrotropic analysis, particularly UV and HPLC she is performing. And this her work, she has done the analysis of cefixime tablet using reverse phase HPLC using this solution, aqueous solution is mobile phase, 6% weight by volume aqueous solution of sodium acetate, adjusting the pH to 6.2 with acetic acid, means without any organic solvent, this aqueous solution was used as mobile phase. And of course, the details you can see in this published paper, this reference is there, okay? And you can ask me, I can send you the published paper also if you want. So in this way, she has done this work. Another work of Remy madam in this reverse phase HPLC. She has analyzed tablets containing two drugs. One tablet containing two drugs, paracetamol and diclofenac sodium, combined doses for. Now these tablets have been analyzed by reverse phase HPLC using 5% urea solution as mobile phase, aqueous solution of urea, 5% as mobile phase without any organic solvent, no acetonitrile, no ethanol, methanol, etc. like this. So in this way, what we are saying that without the use of any organic solvent, you can perform the reverse phase HPLC. But now you listen one sentence from me that for all water soluble compounds, all water soluble compounds, reverse phase HPLC is possible using mixed hydrotropy or mixed solvent system or hydrotropic solutions as mobile phase without the use of any organic solvent. I did not add the word water insoluble drug. For water insoluble drug, for reverse phase HPLC, there are very so many limitations. So you forget about those. If you want to carry out the work, you should select a water soluble compound. For that, you can develop the hydrotropic method or mixed hydrotropic method. Now, mixed hydrotropy. I told you that hydrotropy is about 100 years old concept, but no one has started mixed hydrotropy. I have started this mixed hydrotropic solubilization in the year 2008. It is Jagwani has done this work. Now, M-Pharma student, this is the M-Pharma project. If you want the soft copy of these theses, I can send it to you also, whether you are a student or teacher. Okay. Now, what he has reported, he has utilized fusamide as model drug. The solubility of fusamide was determined in different systems. In water, he has reported this is the solubility in water at room temperature. He has made four hydrotropic solutions containing individual hydrotropic agent in 40% strength. Urea, this is the solubility achieved for fusamide. Sodium acetate, this is the solubility. Sodium benzoate, this is the solubility. Sodium citrate, this is the solubility. Then I told him, it is Jagwani, to make about 15-20 blends. He has made those blends and checked the solubility. So out of those blends, I am giving the examples of three blends in which there was very good solubility of fusamide. These are number 6. 15% sodium benzoate, 5% sodium acetate, 5% sodium citrate, 15% urea. Total is 40%. Always for all brands, the total was 40%. 40% dissolved hydrotropic agent. Okay. So in this particular blend, the solubility was 4.2%, which is nearly double than this. So by using this mixed hydrotropic solubilization, there was synergistic solubilization of drug. Similarly, in case of 7th blend, means 7 number this, the total strength is 40%. This is the solubility, synergistic solubilizing power. This 8 number, synergistic solubilizing power was there. So by using mixed hydrotropy, you can have additive solvent character or synergistic solvent action. What is the importance of mixed hydrotropy? You see, I told you that hydrotropy is 100 years old concept. But hydrotropic solubilization could not be employed by the manufacturer, pharmaceutical manufacturers, for the marketing of the formulations. Why? Because a large concentration of hydrotropic agent may be toxic for human being. Okay, so I will tell you how the mixed hydrotropy can be helpful to solve the problem of toxicity. Now you see this slide. Now this slide, as you are reading on this slide, as per Inactive Ingredient Guide 2020, this Inactive Ingredient Guide is a book which gives the percentages of additives which can be employed in pharmaceutical dosage forms. So I have brought for you these 19 additives. Additives are excipient, whatever you say, from Inactive Ingredient Guide 2020. In these concentrations, these uh, additives are safe to be used in intramuscular injection. You see, these are for intramuscular injection. They are safe. So now I will tell you how can you utilize mixed hydrotherapy to develop intramuscular injection of poorly water soluble drug. Now suppose you select from this list 10% sodium citrate, which is a hydrotrophic agent, 10% sodium acetate, which is a hydrotrophic agent, and 10% sodium benzoate, which is a hydrotrophic agent. So 10 plus 10 plus 10, 30% is the total dissolved solids or hydrotrophic agents in your aqueous solution. Now this mixed hydrotrophic solution shall be checked for the solubility enhancement of poorly water soluble drug. The drug which has got good solubility in this particular mixed hydrotrophic solution can be employed for its aqueous injection, aqueous intramuscular injection, because these 10% of all these three, they are safe as per inactive ingredient guide. So this 30% total strength, three hydrotrophic agent, this blend can solve the problem of toxicity issue, and now this type of formulation can be marketed. So in this way, you can employ mixed hydrotropy using the safe concentrations of hydrotrophic agent, making a concentrated solution. Then this solution can be used to make the aqueous injection in the form of solutions of poorly water soluble drug. So in this way, mixed hydrotropy is very useful to develop the pharmaceutical dosage forms. Okay, this is the advantage of mixed hydrotrophic solubilization. Now I am discussing now here the second parameter of mixed solvency concept. First parameter I told you, each and every substance, whether it is a liquid, gas or solid, possesses good solubilizing, means each and every substance present in this universe has got solubilizing power. Okay, this was first parameter. Number two parameter says, now you are understanding that each and every material has got solubilizing power, whether it is solid, liquid or a gas. Okay, so particularly in making the pharmaceutical dosage forms in solution form, you can employ this mixed solvency concept, uh, means utilizing the solubilizing power of safe additives. You can employ to make the your pharmaceutical dosage form. For example, let me explain again by the same list. As per inactive ingredient guide, again these 19 additives I told you that they are safe in this concentration. Of course, this inactive ingredient guide is a very big book, but I brought these concentrations of safe additives in safe concentrations. Of course, these additives. Now, from this, I will tell you how can you utilize the mixed solvency concept, because now you know that each and every substance has got solubilizing power. So, whatever these 19 compounds are there, additives are there, they must also possess solubilizing power. But only thing will be they will have different solubilizing power for different solutes. Now, how can you make a solvent system, innumerable solvent system using this small list of 19 ingredients? Now you see, suppose you make a mixed solvent blend containing three agents: ethanol 10%, sodium citrate 10%, arginine 10%. So total became 30%. Aqueous solution of this ethanol, sodium citrate, arginine in water. Now this blend has got definite solubility, and this solution, this mixed solvent blend can increase the solubility of some of the poorly water soluble drugs. So for that drug, if sufficient solubility has been enhanced by this mixed solvent system, that can be used to make its aqueous injection, because they are safe in these concentrations. So this is one blend. Okay, means one solvent system. Now second solvent system, if you replace arginine by histidine, so ethanol, sodium citrate and histidine in 10%, 30%, another blend is ready. This will have different solubilizing power for your poorly water soluble drug. In this way, by permutation combination, by reducing the concentration or increasing the concentration, suppose you take six things 5%, then also you can make mixed solvent system. So in this way, innumerable safe solvent systems can be developed by the pharmaceutical manufacturers, and these safe solvent systems can be employed to make intramuscular injections of poorly water soluble drugs. Since we have employed the safe concentration, So now in this mixed solvency concept, second parameter means you can increase the solubility of poorly water soluble drug using solubilizing power of additives. Now with example, let me explain you. Now here, if you see, I have employed four solids: sodium benzoate 5%, sodium caprolate 5%, sodium citrate 5%, and Pulak-Samar 407 5%. These are all are solids. Total became 20% strength, 20% weight by volume, and of course pH is nearly neutral, 7. Now this aqueous solution containing four solids means molecules of these four solids, they are available in liquid state for hydrogen bonding and weak bonding forces with the molecules of solutes like this. So in this particular blend, which is a neutral blend, the solubility of several poorly water soluble drugs was checked by me, and there was increase in the solubility of these drugs in this particular blend. Two examples from that list I am giving to you. Furosemide solubility in this particular blend 35 milligram per ml. Otherwise, its water solubility is less than 1 milligram per ml, less than 1 milligram. So 35 divided by 1, about at least 35-fold solubility enhancement is there due to the solubilizing power of these solids. Pyroxicam solubility uh, is in water less than 1 milligram per ml, but in this particular blend solution, 20 milligram per ml at least. So at least 20-fold enhancement in solubility is there. So this is the second parameter of mixed solvency concept. Now I will tell you the examples of formulations which can be developed using mixed solvency concept. So since time is very limited, so let me explain in brief. Now, dry powder injection for reconstitution of poorly water soluble drug candicertan selexatin has been developed in our laboratory for 1 ml injection. Here, of course, it is M-Form project work. And this is the published paper. You can see it is available online. If you put these words on Google search, you will get this PDF. Okay, what the student has done. Candicertan selexatin 8 milligram, this water soluble drug. This can be nicely dissolved by a solution containing 100 milligram sodium caprolate, 50 milligram sodium benzoate, 50 milligram sodium acetate. So all these finely powdered substances together with drug, they have been kept in a vial. And in vial, when you add 1 ml water for injection and you reconstitute, you will get a clear solution because of the solubilizing power of these solids. Solid dispersion can be made with the help of this concept. Here in this particular MFAR project, of course, this paper published, it is available online. You can see this on Google search, it is available. Furosemide poorly water soluble drug 2.5 gram has been dissolved by solubilizing power of 1.25 gram sodium citrate, 1.25 gram sodium acetate, 2.5 gram beta cyclotaxane, 5 gram sodium tetrate. So when these solids were dissolved in water, a small quantity, then drug was dissolved in clear solution. Then water was removed by heating on water bath and all that with a string. And when this was dried, you get solid dispersion. It is sieved through fine sieve. So this is the solid dispersion of your drug furosemide. So it is fast relief when the dissolution was study was done. The rate of dissolution was found very good. Okay. Now after this, mixed solvent system can be used to develop liquid solid system. Liquid solid system, we employ non-aqueous liquids to increase, means to dissolve the drug, then they are adsorbed on adsorbent, and then you make it a tablet or capsule. So here in this particular MFAR project work, this is the published paper reference. It is there. Paper is available online. What a student has done. The solubility of pyroxicam in propylene glycol was less than 5 milligram per ml, but the solubility of pyroxicam in the blend containing 10% weight by volume sodium caprolate and 10% weight by volume sodium acetate in propylene glycol. The solubility was about 120 milligram per ml. So now what you are seeing, the solubilizing power of these two solids, sodium caprolate and sodium acetate in propylene glycol, it is increasing the solubility of pyroxicam. Again, the reason is same. The molecules of these solids are in liquid state for hydrogen bonding and weak bonding forces. Okay. So in this way, what you have done, you have increased the drug loading, and now in a small solution, you can dissolve the dose of pyroxene, which is 20 milligram, and you can make its liquid solid system. How? Now you see 100, you see this is the solubility, 120 milligram per ml. So you will take, suppose it is 100 milligram per ml. So you will take 1 ml of this 100 milligram per ml solution of drug. Okay, means you will make 100 milligram per ml solution. Because of these two solids, the solubility has been increased. Now, when you get a solution, clear solution, then it is adsorbed with the help of microcrystalline cellulose to make it free flowing. Aerosol is used. Okay. Now, so this system contains the 5 doses 20, 20, 20, 20, 20, 20, 20 means 5 doses of 20 milligram pyroxicam. So you can make 5 tablets of 20 milligram using this because you see 20 milligram will be present in about 0.2 ml. 0.2 ml means in nearly 200 milligram. Adsorbent about 400, 500 milligram. So 700 milligram free flowing powder can be compressed to make tablet or can be filled in a capsule like this. So by increasing the drug loading in liquid solid system, you can develop the liquid solid systems of poorly water soluble drug for fast release. Now, similarly, aqueous injection for poorly water soluble drug using mixed solvency concept have been used. This is the MPAR project of student. Similarly, here dry powder injection for reconstruct this is another work, indomethacin. And here, of course, the published paper reference is there. Now, mixed solvency concept can be used to make a new safe solvent system, as I have explained earlier. Okay, now coming to now, vaginal film has been developed by MPharm student. Metronidazole was the drug selected. Okay, now the size of film was reduced by mixed solvency concept, increasing the drug loading. Similarly, drug loading can be increased in self-amplifying drug release system. Here, published paper references there. Here, in particular, this drug selected was candisultan seleccetil. Okay, now, a soft copy of thesis you can ask, I can send it to you. Improvement of drug loading in oral film to reduce the film size by mixed solvency concept. This in development of fast dissolving oral film, a poorly water soluble drug amlodipine mesylate. This work has been done by MPharm student. Okay, the published paper reference is there. In this also there was a reduction in the size of the oral film. Now this means you can you can use the solids for extraction also. Briefly, I will give you because the time is very less with me now. Now you see, firstly I will give the reference of this paper in which our team, MPharm students, they have done this work. Here in this work, what we have done, we have selected sesame oil as the active ingredient of sesame seeds. Okay, now this sesame oil was extracted with the help of solubilizing power of solids. Now here if you see the solubility of sesame oil was checked in melted thymol. So it was found more than 1 ml sesame oil nicely dissolves in 1 gram melted thymol. Thymol melting point 48 degrees centigrade nearly. So melted thymol, good solvent for sesame oil, we have checked. Then this thymol was used to extract out the sesame oil from sesame seed powder. Actually, you see, I am not saying you that you employ thymol for extraction, but I am giving you the proof that solids can also be employed for the extraction of active constituents. How? 3 gram sesame seed powder, 3 gram sesame seed powder, 9 gram thymol in a test tube, 9 gram thymol. Now, water bath, heating at about 48 degrees centigrade, thymol gets melted. Okay, and during melted condition of thymol, the test tube was shaken. During this shaking, melted thymol dissolved sesame oil present in the sesame seed powder. After 30 minutes shaking, it was strained through a cloth. Okay, and strained liquid containing melted thymol together with dissolved sesame oil was kept in oven for about 1 hour at about 70 to 80 degrees centigrade. All thymol was removed and sesame oil was remaining because it is a fixed oil. Okay, in the same way, melted menthol has been used for extraction. Ethanol solubility has, you see, ethanol is a poor solvent for sesame oil, but when we add this ethanolic solution of, when we prepare 50% weight by volume thymol solution in ethanol, now the solvent power of ethanol is increased and now it becomes very good solvent for this sesame oil. And this solution at room temperature, thymol 50% in ethanol at room temperature, 3 grams sesame seed powder, 9 ml this solution, shaking for 30 minutes, filtration, removal of ethanol and thymol at about 70 to 80 degrees centigrade in 1 hour. Then there was remaining this sesame oil and all that. So in very brief, I am telling you that solids can also be nicely employed for the extraction of active constituent. Those who are interested for extraction work may contact me. I can tell you what to do. How can you do some new work, patentable work using this the solubilizing power of solids. Now coming to this suggestion. Now I am directly coming to the information. I have made 7 YouTube videos of about 40 to 45 minutes duration. Each video is of 40 to 45 minutes. If you put these words, eco-friendly lecture series number 1 on Google search, you will get this topic. Eco-friendly and economic UV spectrophotometric analysis of poorly water-soluble drugs by application of hydrotropy, and mixed solvency concept without the involvement of any organic solvent. Okay, so this video you can see eco-friendly lecture series number 2. If you put these words, you will get eco-friendly and economic trimetric analysis of poorly water-soluble drug by application of hydrotropy, and mixed solvency concept without the involvement of organic solvent. B.Pharm students can do such type of nice work. They can imply the trimetric analysis of poorly water-soluble drug. They can use UV spectrophotometric analysis of drug. And of course, the student can directly contact to me for if he requires any query or any discussion he wants or she wants. Okay, now coming to, sorry. Now this number 3, eco-friendly lecture series number 3 is for each and every substance, whether gas, liquid or solid, present in this universe has got solubilizing power, mixed solvents concept. So this third. Now number 4 is for eco-friendly and economic analytical techniques for TLC of compounds. TLC can also be performed by B.Pharm students. Okay, very economic and without organic solvent is the beauty of the method. Without organic solvent, you are able to perform the TLC of the compound. Please see this video. Number 5 is for reverse phase HPLC. Reverse phase HPLC, I told, for all water soluble compounds, you can use this reverse phase HPLC using hydrotropy, or mixed solvency concept. Eco-friendly lecture series number 6 is for dry powder injection for reconstitution of poorly water soluble drug. If suppose some M.Pharm student is going to perform, want to develop this system, he should see this one, and it is also very novel concept, and of course the work is patentable. Number 7 is for to make innumerable eutectic liquids. You can make innumerable eutectic liquids with the help of mixed solvency concept. For what purpose you want to make innumerable eutectic liquids? For extraction, for synthesis of compounds, for analysis, for formulation purpose, and all that. So in this way, you can see these 7 videos. Now something about the review article on hydrotropy. So this the latest, you will say, the review article on hydrotropy by Yasi Thakur. Eco-friendly and economic, of course, this full reference is there. PDF is available online. Search on Google. This on mixed solvency review article. These details are there. Okay, means reference is there. You say the work which has been done from 2009 up to 2020. You can see in this particular paper. Now a book which gives a chapter number 5 on hydrotropy, and mixed solvency concept. This can be seen in this particular book, which has been published recently in 2020. Science Direct book is there. Now it is, thank you, but very important thing is students and teacher, they can collaborate, means they can come contact with me. They can be in contact with me on my WhatsApp number. This mobile number is on WhatsApp 94066219007, and this email ID is there. So students directly or the teachers directly can contact me. So this is also very important. Now in this way, now I have finished my lecture. Now I am coming to you. I am stopping the sharing. Okay. Okay.
Sir, good evening.
Namaskar. Good evening.
Namaste, Namaste, sir. So I'm Professor Yoganand, Department of Pharmaceutics. I'm having some
Okay.
academic interest towards your work, sir. So
Okay.
hydrotropy is one of the important method for enhancement of aqueous solubility of poorly water soluble drugs, no doubt.
Which which
But
which
at the
which
same there are
method?
so many
Which method you told?
hydrotrophic methods.
Hydrotropy. Okay. Okay.
So there are so many other alternative methods are there, sir,
Hmm.
regarding when we are going for complexation, usage of surfactant system. So there also we can go for solubility enhancement. In
Hmm.
which way, in what
Hmm.
advantages we can get it from this hydrotrophic solvent
Okay.
system, sir?
Okay. Okay. You see, hydrotropy, of course, better is to utilize the mixed solvency concept, because mixed solvency concept you can use the particularly for pharmaceutical formulations. You can
Yeah,
employ the solubilizing power of additives, as I explained in my lecture. Is if you see the inactive ingredient guide, from that you can select the safe additives and safe concentration. And if you imply those concentrations, say for example, I told you example of 10, 10, 10% of three things. So total became 30%. So this is why this is better than co-solvency or then surfactant solubilization or your complexation or single hydrotropic solubilization, because in this together with the drug the amount of solubilizing agent required, while whether it is co-solvent or it is surfactant or it is complex agent. Now the large concentration of single solubilizer may be toxic, but smaller concentrations of different additives may be safe. So in this way, mixed solvency concept is very useful to carry out, means to prepare the pharmaceutical formulations. Okay, means actually what we are going to do, we are solving the problem of toxicity. So you see, I told you that hydrotropic solubilization is about 100 years old
100
concept.
years.
And if you will see in the market, you will not find any product based on hydrotropic solubilization. The
Yes, sir.
reason is because of the large concern. Means you see, suppose some researcher has developed a aqueous injection, intramuscular injection using 30% sodium azure solution, single formulation made with the help of mixed hydrotropy. Mixed hydrotropy is better, and I tell you that in Egypt there is scientist Hussein. He is still using mixed hydrotropy to develop the pharmaceutical doses form.
Right.
So I have started this mixed hydrotropy in the year 2008. It is very useful. If you want to use only mixed hydrotropy, you can develop your doses form. But in analysis, you can use anything, means hydrotropy, mixed solvent system. But as far as the formulation, pharmaceutical formulation part is there, we should imply the solubilizing power of additives, because now we know, because up to this time I think you might have not heard before this that all things possess a solubilizing power. But I have seen all these things, and we can nicely imply this mixed dry powder injection for
Right.
reconstitution. You see, listen me please. You see, up to this time, whatever the product you see in the market, which are reconstituted after adding water, you get either suspension or solution. Either they are lyophilized product or they are means a drug together with sodium bicarbonate, so that by rule of pH they get dissolved and all that. But here in mixed solvency concept, you can utilize the solubilizing power of solid type of additives, because they can also increase the solubility of your drug. As I have given one example of sodium benzoate, sodium citrate, sodium caprylate, and poloxamol, which they are in 5% concentration. In this way, if you can plan, you can make dry powder injection for reconstitution, not only injection, but also the dry powder syrup for reconstitution. You will get clear solution, because mostly, for example, you see cefixime suspension in market. You bring the bottle, you add boiled and cooled water, you make, and you get suspension. But the viability of solution is better. So if you can formulate a powder suspension syrup in the form of solution after reconstitution, that will be better. You will reduce the cost. So in this way, this mixed solvency concept is very useful.
Okay, sir. Thank you, sir. Thank you for your wonderful information regarding this. So we have received some of the questions from various delegates and students, sir. I will select only few questions because time
Okay.
is very consistent.
Huh?
So I will
Okay.
ask only few questions. Later, I will come to conclusion of that. Question
Huh?
number one, sir. Uh,
Okay.
uh, Sir, can you please suggest any novel characterization of techniques in formulations? One of the student has been asked this question, sir.
Okay. Shall you repeat the question?
Sir, can you please suggest any novel characterization technique in formulation?
Characterization. मतलब characterize.
Characterization.
हाँ,
Ah,
characterize. Uh, can a student directly talk to me? No. Can he talk to me, student, directly?
no, sir, they are in YouTube.
Acha, they are on YouTube.
Okay, sir.
Characterization, actually, I'm not understanding exactly what is his question. Can you explain this thing? What is his question? What does he
No,
want?
he sent only that question, sir.
Acha.
Phone mat kar kodu.
Okay, another question, because characterization, what does he want in characterization?
Okay, okay. Second question
I'm,
is, second question, sir. What is the maximum limit for using class 1 organic solvents in formulation?
what is the
What maximum limit for using class 1 organic solvents in formulations?
actually no, this can be seen from the literature. I don't know, I don't remember, I don't know what is the maximum concentration of organic means class 1 organic solvent of this I don't know. This can be seen from literature, but
Okay.
I only give the methods which can replace these organic solvent. Okay, just like in TLC, carbon tetrachloride is used, it is class 1 organic solvent, it can be replaced by. So I in deep I did not go in deep of all these.
Okay. So another question is like this, sir. Limitations of using dimethyl sulfoxide in topical formulations.
And these are very specific questions. They are actually they do not come in my this is
Okay, sir.
knowledge system.
Okay.
Okay, so these are our typical questions. Okay, if he can ask something about the solubilization, it is a different thing. So
Okay.
this can be seen in the books and all that. I don't know this.
Okay, fine, sir. Fine, sir. Effect of these eco-friendly solvents on lambda max, sir. What is the effect of
Huh.
eco-friendly solvents on lambda max?
Yes, this I can go answer for this. You
Okay, sir.
see, yes. Uh, you see, suppose if you see, if you do the screening on UV 200 to 400, okay. Suppose
Okay.
your drug in aqueous solution means suppose you are taking, say, for example, dichloronic sodium. If you are dispersing in water, you are dissolving in water, and that is you may say used in UV for its scanning, you will find a particular lambda max in ecosystem that is 276 nm. Okay, and if we use urea solution to dissolve this dichloronic sodium, there is no effect on peak. Peak means peak does not shift. If you are using urea, no shifting of this peak in aqueous solution until unless you change the solvent system, means water, another solvent. There is no shifting of peak using these hydrotropic agents. For example, in case of tinidazole, 318 nm is the peak in aqueous solution. But in presence of sodium benzoate, also it is the same peak. So there is no shifting of peak in hydrotropic systems. No shifting in aqueous solutions. No shifting.
Okay, sir. Okay. Thank you, sir. Thank you. Uh, remaining questions, we will send it through your mail, sir. Can you please
Okay.
suggest the answer for the same? So with
Okay.
this, I will come to the conclusion part. Today, we are very enlightened with your valuable information regarding the usage of solid shell, replace the organic solvents. Today, we are using many organic solvents. They are very carcinogenic and causing so many problems also. So, in spite of that, when we are going for these solids, definitely we can make use and we can avoid these problems what the organic solvents can cause. So, very much thankful for your valuable information, sir. And I will go for a vote of thanks. Good evening to all. On behalf of SGM Vidyapita, SGM College of Pharmacy, and Department of Pharmaceutics, Chitradurga, Karnataka, I take this opportunity to propose a vote of thanks to those who are directly or indirectly contributed to the seminar a widely employed solid shell replace harmful organic solvents in future. Definitely, it is a very valuable thing, sir. Uh, mixed, also organized by our institution. At the outset, I take this opportunity to thank our chief guest and resource person of today's session, Dr. R.K. Maheshwari, sir, Professor, Department of Pharmacy, Sri GS Institute of Technology and Science, Indoor, Madhya Pradesh. We are really enlightened with your knowledge and presence, sir. Thank you. Thank you very much, sir. I would like thank to our principal for his enthusiastic support to carry out this webinar, online webinar, and at the same time, a special thanks to the organizing committee, teaching and non-teaching staff of our teaching to their for their unflinching support and coordination. Our heartful thanks to our students and registered delegates from different parts of India for active participation. With these warm words and a kind message, we move to the end of this today's session. Thanking you, sir. Thank you very much for your valuable time you have spent with us, sir.
Again, let me thank all of
Sir,
you.
thank you.
that-
Thank you, sir.
that
Thank you very much.
thank you. You have given me a chance to deliver the lecture. So I am thankful for you. And one
No, sir.
request I will- one
It is our
more thing I
pleasure.
We
want
got
to
the
tell
chance.
you.
We got the chance to
We got the chance actually
yeah, sir.
Okay.
to learn from you.
Okay. You may start some of the projects on this solvency system.
Definitely, sir.
So-
Sure,
Definitely
sir.
we are going-
Okay.
Okay, sir.
Sure, we
Thank
will
you.
Okay.
contact, sir. Some
Namaste,
of the inform project we will give it to our students, sir.
Okay.
Thank
Okay.
you, sir.
Thank you.
Thank you, sir.
Thank you.
Okay. May I leave? Okay.
Thank you, sir. Thank you.
Okay.